Okay, this program's had a few glitches, and I don't know if it's the space on the computer or what's happening, but I've already kind of solved this, so I'm going to point it out to you, and then we'll try to continue going live, all right? We use substitution again, and if you look up here, then I took my first equation, just like I did on the other problem that we just looked through, and I solved it for x by subtracting 2y from both sides and subtracting z from both sides, which of course gave me a negative 2y and a negative z in my new modified equation. So we got x equals negative 2y minus z plus 8, and that's our new modified equation 1. So I got equation 2 marked here and equation 3. And then we take this equation 1 and we're going to plug it in to equation 2. So in order to do that, you write this whole equation with a lot of room where the x goes. Look, there's my 2x would go in here, plus y minus z equals 4. And in place of that x, right, we're going to put this whole equation. We're going to put negative 2y minus z plus 8. And then we simply just solve this equation. As we distribute that 2 through, we get 2 times negative 2y is negative 4y. 2 times negative z is negative 2z. 2 times 8 is 16. And we drop the y and the z. Kind of distinguish your z. Still got equals 4. Then we had our negative 4y and our y. Those make negative y, 3y right here. And then negative 2z and negative z made negative 3z. And we dropped down our 16. So this step was just combining like terms. After this, we subtracted 16 from both sides, and 4 minus 16 was negative 12. And then we're like, why don't we just solve for y? So we kept moving here. We added 3z, right? We got negative 3y still over here equals 3z minus 12. And at this point, we wanted to solve for y, so we divided by negative 3. Well, this divided by negative 3 was y. And 3z divided by negative 3 was negative z. And negative 12 divided by negative 3 is 4. And I have just marked this equation 4. So now we have 4 equations, and this one we've had x removed from. So our goal is to take equation 3 and remove x by plugging in this new value for x that we've kind of assigned up there from equation 1. So we're going to try that again. So we're going to take this equation and we're going to write it. So this is going to be our next step. We're going to substitute our new equation 1 into equation 3. And we're going to give it a shot. All right, let me section this off so we don't kind of go over here. All right. So I'm going to write equation 3 without the x. So here we go. We're going to say, we're just going to put nothing there and say plus y plus 3z is equal to 7. All right, and then our x comes down. So in front, I'll put it in parentheses here. Negative 2y negative z plus 8. And honestly, there's nothing to distribute, so the parentheses don't do much here. We just combine like terms. Negative 2y and y are negative y, right? Negative z and 3z are positive 2z. And then we got plus 8, right, equals 7. Let's simplify a little bit more. Let's go ahead and well, you know what? We can subtract 8 minus 8. We could even add y. That's kind of nice and simplified. We'll add y. And we'll get 2z equals negative 1 plus y. All right, I'm going to stop there, and we'll see how this works out. All right? I don't have to completely solve this because what I really wanted is I wanted a new equation 5. And then you use equation 5 and equation 4 to solve. So if you notice this right here, my y is equal to negative z. Let's make sure that looks like a z plus 4. So my next step is to substitute, right? It's going to be substitute our new equation 3, all right, into our equation 5. And you know what? I should have actually made this 4. So let's go ahead and make this. Oh, no, we did that right. This is our new equation 4 up here. So we're good. Our new equation 4 right there. So we're going to substitute our new equation 4, that was the modified one here, into equation 5, these two. All right? So I'm going to write equation 5 without the y because equation 4 solved for y. All right? So here goes equation 5. It's 2z equals negative 1 plus, and instead of y, I'm going to plug in this, negative z plus 4. So if I keep going with this, obviously I can add z to both sides, plus z. I'm going to go ahead and combine the other side real quick. This gives me 3z equals 3. And wow, look at that. We've got z equals 1. And I'm going to go ahead and I'm going to kind of box this off on its own. We know z. All right. So I'm going to take something, this z, and I'm going to plug it into maybe equation 4 to solve for y. So I'm going to write it. I'm going to substitute z equals 1 into, and we'll call that equation 4. Equation 4. So here we go. We take equation 4. We got y minus, and instead of z I put 1, or y equals, sorry, instead of negative z I put negative 1, right, because z is 1, it goes in right there, plus 4. So y equals 3. And I'm going to go ahead and box that off. All right, so now I know z and 3. So I'm going to go back to equation 1. I'm going to say substitute z and y into my new equation 1. So here I go. I'm going to kind of zoom out so you can see the old equation. There's my modified equation. It says x equals negative 2 times y. Well, y we know is 3. All right. So minus, right, z, and z we know is 1, plus 8. So x equals, we'll do multiplication first, right? That's a minus. I better make sure that looks like a minus there. So we got negative 6 minus 1 plus 8. So x equals, and we can see that's a 1 right there. So this equation, if we did x, y, z, would be this. It would be 1, 3, 1, comma. So we can see that there is a lot of work, right? But we solved 2 equations with substitution. And I'm going to post this today, and we'll hopefully get more posted tomorrow. But it's getting kind of late, and I got to get home.